the form of the sine or cosine function, a general expression Vt equals to Vm sine omega t plus phi, or in cosine Vt equals to Vm cos omega t plus phi. Okay, for example here, I give you one example here of the sine function waveform. Okay, example here. Okay, example, one complex cycle from this waveform is from 0 to 2 pi, or 0 degrees to 3, or 0 degrees or 2, or 2360 degrees. Okay, equals to 2 pi. This is one complex cycle from the positive side to the negative side. Okay, so from this waveform you can get the maximum value, or V peak is equals to Vm. Okay, V peak equals to Vm. Okay, or we call it maximum value. The most maximum value is V peak in this waveform. Okay, one complex cycle is from 0 closing to 0 closing. For example, here one complex cycle from 0 to 360 degrees. Okay, we can get one complex cycle here. Okay, we can get one complex cycle here. Or you can get the value of t is from V peak to peak. For example, okay, we have peak here one and peak positive one here, so you can get here also one complete cycle. Okay, or at above is also can. Okay, from here to here, we peak to peak. Okay, one t. Okay, what is Vm? Okay, what is Vm? Okay, Vm is the amplitude of the voltage, the maximum or peak value of the voltage, unit volt time. It can be current also. Okay, this just for example, it can be current also. Okay, one complex cycle, this is a definition, right? The time taken for an AC waveform to complete one full pattern from its positive half to its negative half and back to its zero baseline again. Okay, that's what we call one complex cycle. Time period T, the time taken to complete one cycle, the period of sinusoidal function. Okay, T equals to 1 over f, 1 over frequency. The unit of T is in seconds. Okay, frequency, the number of cycle per second, the frequency of the alternating quantity. Frequency equals to 1 over t. Unit is hertz, or you can write down as hz. Okay, hertz, the short form. Okay, phi. What is the phi? Phi is a phase difference of phase angle of the sinusoidal function in degrees or radian. So be careful of that. Either in question, either in degree or radian. Okay, what is angular frequency? Omega. Omega is angular frequency. Omega equals to, the equation is omega equals to 2 pi f. 2 pi f, the unit is radian per second. Okay, what is omega? The definition is the rate of change of angular displacement. The rate of change of angular displacement is theta during rotation. Okay, I will explain it later in the later slide. Okay, and the equation for V peak, okay, in RMS value is equals to is Vm over Z2. Okay, RMS value is we cater the value of AC to become as a DC. Okay, it will explain later in the later slide. Okay, frequency is the number of occurrence of a repeating event per unit of time. The period is the duration of time of one cycle in a repeating event, so that the period is the reciprocal of the frequency. That's mean here the T equals to 1 over F. Okay, the T equals to 1 over F. So it's a repeating event per unit of time. Yang kita belajar sebelum ni kan, maknanya kalau 60 Hz bermakna 60 kali 60 kali the repeating event by duration in 1 second, for example. Okay, for example, you have if a newborn baby heart beat at a frequency of 120 times a minute, bermakna 120 kali dia punya denyutan nadi dalam masa 1 minit. Ini bukan 1 minit. Okay, so what is the value of T? Okay, so you know, okay, we have the frequency equals to 120/0. Okay, 120/0. So what is the T? T equals to 60, the 1 over of 60 over 120. So you can get the T is 0.5 seconds. Okay, 0.5 second. Okay, 0.5 second. Yes, 0.5 seconds. Okay, so the application of the frequency is an important parameter in science and engineering. Okay, is to specify the rate of oscillatory and vibratory phenomena. For example, the vibration. Okay, the vibration. Okay, for example here, vibration, audio signal, sounds, radio wave, and light. Okay, all have the specific value of the waveform lah. Okay, so from here we have the lowest frequency and the highest frequency. Okay, for your information, okay, you see the lowest frequency cycle. Okay, you see the sinusoidal function here. Okay, and you compare it with the highest frequency. Okay, so the upper one is more slower. Okay, the upper one will more slower because you see the interval of time and the amplitude. Okay, it will oscillate in very slowest rate. Okay, the big size of the complete cycle one. Okay, but if you see the fastest rate of the frequency, okay, compared to the upper one, you see the one complete cycle is very in a short time. Okay, that means, okay, the upper one is more slower and the very bottom one, okay, is the highest frequency because it's generated in very fastest rate. Okay, for example, the other, okay, contoh yang pertama, okay, from the equation cosine function here, and you must find, okay, the value of period of time t and frequency f. Okay, it's given here Vt equals to 20 cos dalam kurungan is 2 pi dalam kurungan ni 40 t. Okay, 2 pi 40 t. Okay, and you give the waveform here. Okay, from waveform, okay, starting waveform is already given to you the waveform, so you find how to find the t, how to find the t and f. Okay, so you have Vt equals to 20 cos 2 pi 40 t. Okay, apa kita punya tu, kita punya ni 2 cos omega t plus v. Okay, the general equation of from the general equation. So we compare to the graph. Okay, from we peak to peak. Okay, for peak to peak you can get here. Sorry. Okay, we peak to peak. Okay, you can get from here. We peak to peak. We peak to peak. Okay, we peak to peak. Okay, you can get the value of t. Okay, the starting point is here. Okay, the starting point is here. Okay, from this one you can get the equation from peak to peak. Okay, so this one is 0.03. Okay, 0.03. Okay, so the cutting here is 0.005. Okay, 0.005. Okay, this one is 2 is 3. So one we peak to peak you get 0.03 minus 0.005, so you can get 0.025 seconds. Okay, this is a t. Okay, so f is a reciprocal of t, 1 over 1.125. You can get 40 hertz. Okay, this for first example. And the other choice, okay, the other method how to get the value of t, also you can get from zero crossing. Okay, what is zero crossing? Okay, from here, okay, from starting point of 0 here, okay, from starting point 0 here, and one complete cycle in here. Okay, so you can get zero crossing. Okay, zero crossing is from the value of 0.025 until 0. So you just subtract the value, you can get same. You can get the same answer, 0.025 seconds. So the f is 1 over t 40 hertz. Okay, or you can get from the equation. Okay, from the equation, you know Vt equals 20 cos 2 pi 40t. Okay, omega equals to, okay, Vt equals to 20 cos omega t plus phi, right? So omega here, cos omega equals to 2 pi f. Okay, 2 pi f. Now the f, okay, 2 pi f. Okay, 2 pi. Now the f is 40. Okay, you can get directly frequency is 40 hertz from the equation directly. So t equals to 1 over f, you can get the same answer, 0.025 seconds. Same. Okay, so from graph you can get the value of t by determining the complete cycle of waveform by zero crossing or peak to peak values. Okay, macam tu lah tadi kan. Okay, next